All right, so how about an example? Well, suppose that we have a right triangle here with an angle theta and side lengths 3, 4, and 5. How can we calculate the three trigonometric ratios, sine, cosine, and tangent, using the magical incantation SOHCAHTOA? Well, it's easy. First, sine of theta. Well, that's opposite over hypotenuse. So, opposite over hypotenuse is sine. So the opposite side is 4, the hypotenuse is 5, and there we go. 4 over 5. Okay, what about cosine? It's just as easy. So cosine of theta, that's adjacent over hypotenuse. So which side is adjacent to theta? Well, there's two sides that are next to it, but one of them is already called the hypotenuse, so we care about the other one. That's 3. That's the adjacent. So 3 over h, the hypotenuse, is 3 over 5. Finally, tangent theta. Well, that's no harder. TOA, opposite over adjacent. 4, because that's opposite the angle, over the side next to the angle, which is 3. And there you have it, folks. All right, have you had enough? I haven't. Let's do another one. Okay, so same thing. We have a right triangle. We have an angle theta. Let's find sine, cosine, and tan. Okay, sine. So, opposite over hypotenuse. Opposite angle theta is 12. Hypotenuse, longest side, 13. So this is 12 over 13. Okay. Cosine. Adjacent over hypotenuse. What's adjacent? Fancy word for next to. So 5 is the side next to the angle theta, and the hypotenuse is 13. Last but not least, tangent. What's tan theta? TOA. Not toga, TOA. Opposite over adjacent. So opposite is 12. Adjacent is the side next to the angle. 12 over 5. And that's it. Okay, now what if we want to calculate these trigonometric ratios, not for one angle, but for two angles in a right triangle? Well, it's just as easy. In this case, the angles are named alpha and beta. These are the first two letters of the Greek alphabet. Get it? Alphabet, alpha, beta. You got it. Okay, sine of alpha. Well, sine, so. You might think, so what? Well, so tells us opposite over hypotenuse. Opposite to alpha is 15. And the hypotenuse is 17. Whoops, that should be 17. Big mistake. Okay, 15 over 17. All right, what about cosine? Well, cosine of alpha, that's, we know right here, adjacent over hypotenuse. So next to side alpha, or next to angle alpha, is side 8. And the hypotenuse is 17. 8 over 17. Finally, tangent alpha. TOA, opposite over adjacent. 15 over 8. And that's it for alpha. What about beta? Same difference, but remember opposite and adjacent refer to the opposite and adjacent of beta now. So for instance, sine of beta is the opposite of beta over the hypotenuse. So opposite to beta is 8, and the hypotenuse is 17. So So sine of beta is 8 over 17. Okay, cosine beta, adjacent over hypotenuse. Adjacent next to angle beta is side 15. So 15 over 17. And finally, tangent of beta. So tangent of beta, TOA, is the opposite of beta, which is now 8, over the adjacent, which is 15. See what happened? The side that was opposite beta, namely 8, is the side that was adjacent to alpha. And similarly, the side that was opposite alpha, namely 15, is the adjacent to beta. So when you go from this angle alpha to this angle beta, well, sine and cosine get flipped, and tangent, these are flippy dippies of each other. So the fancy word for flippy dippy, reciprocal. Don't forget.